Okay. Nearly there. Especially the 22 months. Both first to the stream and first to 22 months, for sure. Thank you so much. Nearly 2 years. Appreciate you. Tomorrow is your first last exam this year. Oh, that's hype. Hopefully the first and last exam. How long of a break do you get? Is it just gonna be like a week or something, or what? Last class exam for my bachelor. It's actually also this year. Oh, like to actually get your degree? Uh oh, I saw you put something there, Renato, but I can't read it if you retract it. Um Not this year, like next year on March if anything works out, but last semester is without exam. Really? That's very different from how degrees like typically work here. Let me scroll. Okay, so actually, I mean, we might have degrees that work like that here, but that's not at least the experience that I normally hear about. I feel like you're just always taking. This question looks pretty difficult, by the way, Renato. I feel like is this a competition question? uh, at least for my degree, what am I trying to say? You're basically you're always taking classes that are pretty much like normal. Like the only special thing I had to do was take 2 semesters of a class called Methods of Applied Math, and there wasn't even a real overarching project we had to do. I don't think like there were final exams for that class, but it wasn't like it was still contained within a class. I guess it's not like something separate. So you basically just get enough credits, and or like you have to pass certain classes. You have to take enough classes to get enough credits, and then you just put in a petition to graduate, and they say yes or no. And the petition to graduate is just like saying that you've met the requirements of the degree. Yeah, Jed, that's what I'm thinking too. Like the other thing I think to even try with this is factoring that as a sum of two cubes, but like this looks like a competition question, Renato, and I don't know competition math, so I probably won't be able to answer this. How does this formula even work? So like that? I don't think there's a 2. Correct? Okay, thanks, Raven. Yeah, the other thing I think was to try and get some kind of matching thing with the AB plus 4s, but that doesn't seem like it's going to be possible. So yeah, thanks for trying to ask me a question. I do appreciate it, but this looks a little too far out of my wheelhouse. I was just wondering if you could just choose an A and figure what B must be, but they have to be integers, so that makes it a lot harder. I mean, honestly, guessing is probably this is guess and checkable. I think it'd be really annoying, but that'd honestly be the best thing that I can think of. No, I mean, it'd be really hard to guess and check it by hand though. You have to get some pretty. You have to figure out what stuff like 12 cubed is, which I mean that's not that bad, but it'd be annoying because you have to do it like for a bunch of numbers around there too. And it's probably not the way that you're. There's probably a much better way of doing it. So for now, I'm just gonna go back to doing this E&M problem I've been working on for probably 2 weeks now. I just have a. I just want to figure out the interpretation of part C, like the physical meaning of this constant piece. If you have infinite capacitance, it's basically an RL circuit, but with a constant. And so something with a high capacitance um God damn it, I don't know how capacitors work. The disk requires wait. It has a disk has less capacitance than a sphere. The disk requires a smaller amount of charge to attain a given potential than does the sphere. It requires so something with infinite capacitance needs a lot of charge to reach a given potential. I don't know. Trying to see if they... I don't know. Hopefully they get into the interpretation of this here for a parallel plate capacitor. Okay, you know what? Maybe I don't need this. Maybe the meaning of this constant is that the capacitor is hanging on to charge to keep the voltage at a certain minimum. Maybe that's what's happening. You know, I feel like okay, that's not a bad guess at the answer. This is number 8.6. Maybe let's look at what the answer actually is. Did I ever look at for part A and B? I don't think I did. What was part A? Doing the R to 0 limit. It should look like an LC circuit. I get alpha equals R over 2L. Wait. What? Oh no, uh I do not. Alpha equals R over 2L was something that was like given throughout the chapter. Oh yeah, Joseph, that giant banner was annoying. Hey, Arav. Okay, so A is more or less good. B, I get that it behaves basically like an RC circuit. Okay, then for part C. C goes to infinity, then R greater than 2L over 2 root L over C. You're getting the overdamped regime. The voltage, wait, if C is infinite, the voltage across the capacitor is 0. Okay, yeah. So the capacitor can be ignored. I forget what I said, to be honest. I thought I was hanging on to charge. Maybe it's the exact opposite of what's happening. No, it is an infinite reservoir of charge. Or, I didn't say infinite, but... Oh, my mic didn't just pick up that sound. If there was like a little like clang sound, let me know. It'll become basically a constant current. Hmm. Okay. Uh, like usual, I feel like I only got that half right at best, but I'll take it. I want to do a lot more problems from chapter 8, but I should really get back to doing the mechanics. So we might go back to doing that. Let me switch to a different journal plus plus file. Save that. Chapter 5. Okay. And then where do we leave off in chapter 5? uh on number 9, I think it's the one that I rage quit on. I'm just gonna move on to number 10. I don't want to even reread 9. Yeah, go ahead, Colton. Spring with constant K and relaxed length L stands vertically on the ground. Bottom end attached to the ground. The stem is attached to the top and then lowered down to the ground so that the spring is compressed to 0 length. This is then released from rest and accelerates vertically upward. Hmm. I think I can see the idea of this one. Um, Basically, at the start, you have a spring that's been compressed length by L as constant K. The potential energy due to spring is, oops, 1/2 KL squared. And by the time it gets all the way up, it's gonna, it's gonna have a combination of gravitational potential and spring potential. Okay, this isn't as simple as I thought it'd be. Let me look at Colda's question though first, because I see it's posted now. Given the A, B, C, D are position vectors of 4 points forming a tetrahedron. A tetrahedron is like, it's four-sided and the four sides are equilateral triangles. This feels important to be clear on this. Hey, Zach. Happy Tuesday. Right. Okay, a regular tetrahedron is all edge lengths equal, but it doesn't have to be. Okay. Other than that, it is what I was imagining, though. We're doing well, Zach. We define big X to be something weird. Are these X's scalars? Yeah, they're natural numbers in 0. Lots of programming. Ooh. It's exciting, though. So this feels similar to that spherical coordinates problem where we have a infinite series prep, of course. Two exciting things. So we're scaling each of these vectors and adding them all up. But we have the constraint that all our scalars have to add up to 2. And our scalars are natural numbers or 0. Let S denote the set containing 4 element subsets of X. Okay. Let T belong to S such that 2D belongs to T. Oh, what the fuck? I don't have enough copy to understand this. Let T belong to S such that 2D belongs to T. The number of possible sets T. So basically, how many 4 element subsets are possible such that 2 times the vector D is included in T? Such that the 4 elements of set T are co-planar. Oh. Hey, SG1. Yeah, so if 2D belongs to T, then that forces X4 to be... Oh. Yes. It forces X4 to be 2 and the other 3 to be 0. I was just wondering if we could have A equals D, or like if these vectors aren't distinct, but they have to be distinct because they point to each of the 4 points of a tetrahedron. So wait, the 4 elements of set T are coplanar. That part makes no sense to me. Four element subsets of X. So we have the same tetrahedron that I guess is being stretched in different ways or collapsed if you use 0. think there's some formula for 4 vectors to be coplanar. I don't remember though. Hmm. I don't get how there's more than one. I mean, I don't get how there's more than one possibility. Well, oh wait. Okay, wait. T is a oh. Okay, so T contains 4 elements. And only one of those elements has to be 2D. The other 3 elements could potentially be anything. The 4 elements of set T are coplanar. If they're coplanar, if all 4 of these are coplanar, uh that means that it's the matrix is rank 2. I think? Question mark? Do a Minesweeper? All right, I'll do that in just a second. Um, I just want to write out this matrix idea. Am I even defining this correctly? Um, do a Minesweeper. This isn't quite right, is it? This isn't gonna come out as well, maybe it does come out right. I want, why, these are 3 dimensional. Why am I making them 4 dimensional? That's 3 by 4. I want a 3 by 1, and that's a 4 by 1. Okay, good. Okay, this feels like something we can do something with here, but let me do a Minesweeper for Zach. And let's use the website that Maxi. Wait. It was Minesweeper.online that Maxi told me about, I think. The no guessing one. Yeah. This is my new favorite. Where there's a like tremor thing? Oh, it's because I'm misclicking. That's why there's like a tremor. Damn. Oh, did you do three in a row? Light blue, red, yellow. Yeah, for Virgin, I feel like this one I don't get as much like empty space, I guess. So like um with the other one, I felt like half of it would be done full for me, just so, like when you get like a big like empty region. This might also be a different grid size. I haven't really checked that, but either way, this one removes the RNG from Minesweeper, and that's a big plus for me. You know what? The issue with my idea here is that this is just T1. Hmm. We would actually have three more of these, and we would need one of them to contain 2D. Like, I guess one of them, the X vector would just look like that. Yeah, X, Y, and Z components coded. You know, we could make that T1. And then like just for example, T2 would be a similar thing. I'll just do like big like a matrix of vectors like this, I guess. But then this now has its own distinct x's. Same A, B, C, and D, different x's. So it needs to be coplanar. I mean, like T2 can be any vector it wants as long as T3 and T4 fall in the same plane. And does the geometry of the tetrahedron help us at all? It probably does. I just don't know how. It's base. Man, this is funny because maybe I'm breaking it down too far. Maybe is T basically a vector space with 4 vectors in R3? It's not quite a vector space because it's not any linear combination. It's only natural number combinations, I guess. Like this must force the other vectors to look a certain way. I just don't know how to think about that. If they're coplanar, then there must be some linear combination, I think, such that, like, let's just pretend m times t1 plus n t2 equals t3, in that o t1 plus p t2 equals t4, or something like that. That's what I'm trying to wrap my brain around. Like, something like this must be true, and that's how we get to the answer. I just don't know how to, like, use that. M, N, O, and P don't necessarily need to be integers either. That's fine. Hey, Central. Dude, I hate this playlist. I'm gonna change the music. I'm just gonna put on that one, why not? What's integer? I guess I'm not sure. Like, these x's, I've been saying integers, but um, it's really like natural numbers union 0, so like non-negative integers, you could say. So basically 0, 1, 2, 3, dot, dot, dot. Like, no, like, fractions or anything involved. Whole numbers, basically, yeah. A language barrier. Oh, okay. Yes. um, it's always hard to judge whether something's like a math question or a language question, and I've made the wrong choice many times. So yeah, basically what that means is the numbers 0, 1, 2, 3, and so on. An integer in general, um, it's like that, but with negatives. So I've been saying integers, but that's not quite right because we would chop off the negatives in our case. It's a terrible Z. Like double Z. That's a little better. So I think the function of telling us that A, B, C, and D form a tetrahedron is another way of saying that these things are linearly independent. Hey, famished. What? Called natural numbers? Yeah, so that's the normal definition. That, or I guess, um, natural numbers are, depending on your context, typically 1, 2, 3. In computer science land, you include the 0, and they still call those natural numbers. But I said in math we normally don't include 0. Here they're being explicit in doing natural numbers unions 0. Getting used to word problems, nice. No, you're good, Raven. To be honest, I'm pretty stuck on this problem anyway, so it's not really a sidetrack. Like, this must mean, this has to mean something clearly, but I feel like I have the pieces. I just can't put them together. Means you're a baboon, and I'm not. Is that a reference? Follow Rafiki, he knows the way. Oh, okay. Lion King. Need more protein bars? They're pretty good. I feel like you make this a way simpler question, Colded. I'm not gonna have a linear algebra to know how to translate this though. Um, I think this question isn't actually that hard if you can get through this first part. But I can't get through this first part. Like, do you have to start looking at different scenarios? Like, I don't know. If we just were to let T2 be, let's pretend 1, 1, 0, 0. In order for T3 and T4 to be coplanar, what needs to happen? Blender topology? Oh, they probably do go together well. I think if we take this T1 and T2 as given, um T3, I'm just gonna put a dot 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 for the same thing as before, should be like, I think there's only, like, we can't ever involve the C vector. So you can do a 2 for the first vector. I guess you can do a 1 and a 1. Do you always like math? No, I thought it was boring until senior, 12th grade. I was about to say senior year of high school, but I realize it doesn't translate to the rest of the world. But 12th grade, like when you're 17 to 18 years old, that's when I took my first calculus class. And I realized that the equations I was learning in physics for projectile motion, like y equals y0 plus v naught t plus 1/2 gt squared, and v equals v naught plus, that's a minus, isn't it? Minus gt, and that a equals minus g, I guess, in this case. I realized that these three things were connected by derivatives and integrals on my own. And that was just like the coolest thing to me, that I'm actually learning math that is relevant to something else that I'm learning. And it's kind of feels like a crime that neither class ever talked about that. But that's the exact thing that like got me interested in actually like learning math. I have a bunch of engineers in my family, so I kind of assumed that I'd be doing something engineering like. Uh, but the university that I went to had a crappy engineering program, so I switched to just math. And here I am. Not directly, but now I am looking it up and can work together in some ways or the other. That's what I like about. Yeah, I hate school in general, and now I adore learning. Nice. One of your hobbies. Content creation side of math is in it too now. Maybe physics when you do game dev. Oh yeah, physics is helpful if you want to make your own like engine. If you want to make your own like game from scratch, you need some physics. I mean, that's I wouldn't call like realizing that on my own like uh in a way that's meaning that I'm smart, but because I'm not sure what your background with math is, right? But at least if you do know like derivatives, it's not a super hard derivative to take just like mentally. But it was just like cool that um I don't know. I already said it. It was cool that I could memorize just one equation and figure out what the other three must be instead of having to memorize three equations. You're a physics student? Oh, nice. Are you like I assume you're at university then? Like what year are you? Hmm. Pseudocode and flowchart. I can start exploring into game dev or just programming in general. Hmm. So you're doing a pseudocode and flowcharts before as like maybe a primer for programming? Fair enough. Year 4, but you paused it, so I'm older. Oh, okay, nice. That's awesome. I ironically like that connection with physics is what made me like math. But then once I actually took a physics class, I was like, man, this sucks. But I think I just didn't have the greatest professors, or they're maybe like not able to teach it the right way because they had to teach it at like a lower level. But studying physics more recently on my own has been super fun. Everything related to optics I find hella hard. I never studied optics, so I can't say for myself. Um, so I think Colton, the real question here is like, what choices of X1 through X4 can we make that assures, kind of things that I was saying before, that T1, T2, T3, and T4 are all coplanar. Uh, One of these vectors is forced to be 0, 0, 0, 2. The other three vectors, um, we can choose pretty freely. Do they need to be different? Yes, they need to be different because these are sets. Uh, this. Ooh. So maybe we've nearly solved it then. Um, Basically, our first choice of x1 through x4 is forced to be this, so that there's no choice to think about there. I think the other three vectors must be in some order in permutation. These three things. Otherwise, we're not coplanar. Um, so this is one combination here. Um, and this is the orders don't matter, right? Because these are sets. So this entire thing is just one big possibility. We don't have to worry about reordering these same vectors. I I think the answer is 3 because no, not necessarily. It might be 4. Yeah, I think it's. Ooh, wait. Yeah, yeah, 4. Um, because we could also have T1, same ABCD matrix. Sorry, well, T1 I'm gonna always take to be this. Now we have to consider. I'm taking this same vector, but I'm gonna rearrange the ones in the zeros. So like this is another potential vector. And so then T3, this isn't right. I'm missing out on possibilities. If we stick with this choice of T1 and T2, this is a possible answer for T3 and T4. But we could also have that, could we not? And we could also have this song has like a clock ticking sound. That's probably what you're hearing. And we can also mix and match, like that choice of T3 and T4 would work, that choice of T3 and T4 would work. Could we even have these T4s? I don't see why not. They're all distinct. Is there anything else that I'm missing? I don't think so. So how many do we get now? So I think I'm claiming any pair of these vectors, of these four vectors would work, which is 4 choose 2. Maybe it's another way of... Yeah, 4 choose 2. Hey, Akarsh. What's the formula for this? Is it 4 over 2? It's probably like that. Which is 6. That makes sense, I think. Yeah. So I think we get 6 possibilities. And we're going to multiply that 6 by something. Like we're going to have analogous situations like here. And how many analogous situations can we name? I'm kind of thinking of it based off permutations of that vector there. I think there's 3 more. So we're going to want to do 6 times 4 total is 24. I think my answer is 24. I don't know if you know the answer to this quoted or not. I'm doing good. A sum? Yeah, feel free to put it there in chat. Or if it's easier, you can put it in my Discord. Why do you choose two? Because we're basically making uh so like the thing that is really important to pay attention with this is the choice of x1 through x4. Those are the things that we're really choosing between. A, B, and C are like constants that are given to us. This was the first pair of like x1 through x4 choices I found that would probably work. But then I also realized that we could have this pair. And then I also realized that we could like, go across these pairs and do those two or those two or those two. So I basically had 4 total possibilities because all 4 of these choices would work with each other, and we're choosing 2 of them. So you don't have to do like the 4 choose 2 thing if you don't want. You could just say like, this vector can be paired up with any of the other 3. So that's 3 choices. Then this vector can be paired with any of the other 2. So that's +2. 3 plus 2 is 5. And then that vector can be paired with that vector, which is your 6th choice. So +1. Hey, Kuzaima. So you don't have to go as far as doing 4 choose 2, but that's just how I did it. And so what I did then is I realized, okay, so in this world where we take that as our second vector, we have 6 choices. And then I multiplied by 4 because I could also have chosen this as my second choice. I could have chosen that as my second choice. Oh wait, maybe there's more than 4. Because there's also this. Oh wait, but then we get crossover. Damn it, it might not be 24. It's probably not 24. I think this is the idea, though, of how you're supposed to do this problem. Wait, so I think from these, there's 3 scenarios then where we have 6 choices. So 18 plus something. And the plus something is going to come from the other choices of T2, which include a 1 at the end. So like that. Not that. Not that. So like these 3 things. Do these 3 choices end up collapsing back into being one of the scenarios I account for over here? I feel like they probably do. Maybe it's actually 18? Because maybe these aren't actually different scenarios. Yeah, I think so. So maybe I'm changing my answer to 18. Because I think these aren't actually different. And there's only 3 choices. There's only 3 important choices, which are these 3 here. So I think I'm saying 18 now. I'm never going to give a confident answer to this one though, because I'm really not sure. But this is what I'm thinking for this problem, at least. Hey, Aurelios. What's up? Can you confirm? Okay. Um, all right. In that case, I think I might move on then because I don't see what else to do with this problem, at least. I still feel like there's some way to think about the rank of a matrix somewhere. I'm not quite seeing how though. Let's take a look at hourly dose of internet's question. Okay, I'm gonna use. I feel like the parentheses might be a little bit off here. I'm gonna use to confirm what the problem is. No worries, Golden. So is it 2 plus 3x squared like that? Is it like this? Hourly dose? Yes. Uh, no, there's nothing really to expand here. I guess we can get a common denominator. So maybe there's like a language issue, but I guess like we could combine these as one, getting a common. Wait, binomial expansion? This doesn't. This isn't a situation where the binomial expansion applies, though. I don't think. Oh, you're saying to think of it like this and do binomial expansion with the negative ones? I don't know why you would do this. I guess you can. Um, Let me look up how binomial expansion works, I guess. I forget. So including the terms up to okay. There. That's what we want. Oh nice, they made a transparent image. All right. So we want to do binomial expansion on, well, okay, let me do some side work in green. 2 plus 3x squared to the minus 1. And we're going out to the x cubed term. So see how it looks, I guess. So I guess I'm taking A, hey, $10. I'm taking A as 2, B as 3x squared, and N as negative 1. And so the first term is 2 to the negative 1. Plus now negative 1 times 2 to the n minus 1. Negative 1 minus 1 is negative 2. times b is 3x squared. Now, we're not going to get an x cubed term. Back to the 3 out first. Does that make it look cleaner? Oh, I did make a slight mistake with that. Back to the 2 out. It's different for negative indices. I hardly use this. I want to see something that's telling me what the formula is supposed to look like. .18 of Calc 2 of Paul's notes? I don't know. It's for positive integer n. Oh, okay. There you go. This is the formula I actually want. Um, okay. And I assume there's a different way to, there's like a slightly different looking formula factor the 3 out, but I'm just going to use this one because that's what Alloy does of internet is saying to do as well. Never struggle with this because I would just give up instantly. That's the spirit, Yanis. Hope you're doing well. So we're going to factor the 2 out just to make the formula match. So we get 2 to the negative 1 times 1 plus 3 over 2x squared to the negative 1. Okay. And now we're going to do our approximation. And this is where the x... Well, okay. So I assume we're going to go out to like the term involving x cubed here. But it's going to... Because we have an x squared already, we're going to have x to the 6th. And I assume that's what they want. It might mean that we can stop even earlier, but... 2 to negative 1 is a half. 1 plus k is the exponent. So negative 1 times x, but x is 3 over 2x squared. And then we're on this term. So minus 1, negative 1 minus 1 is minus 2 over 2 factorial x squared, but x is 3 over 2x squared. And then one more term. -1, -2, -3 over 3 factorial 3 over 2 x squared cubed. And that's as far as we go out. Now let's simplify this. One minus 3 over 2 x squared. Plus 9 over 4x to the fourth. It's kind of funny how the factorials are canceling out. Probably for a reason. Oh, yeah. I guess because if the power is -1, it looks a lot like a over 1 minus r, doesn't it? It's funny. 27 over 8x to the 6. And so I think that's our approximation for that thing there. And annoyingly, we're going to have to do the same thing for the 2 minus x, I guess. So we'll do more side work in a different color. Two to the -1, 1 minus, ooh. Everyone says 1 plus -1/2x. Just to be really clear that this entire thing is the x in that formula. Hopefully clear, at least. It's the intention. Now we're going to approximate. 1/2, 1 minus, I guess 1 plus -1 times -1/2x. Plus -1, -2, 2 factorial, -1/2x squared, plus -1, -2, -3, 3 factorial, -1/2x cubed. Okay, now let's simplify that. We'll get 1/2, 1 plus 1/2x plus 1/4 x squared. These are the most annoying signs ever. The first three are positive and the fourth one is negative? Wow. No, it turns back to positive. Haha. 1/8 x cubed. Okay. And I guess I should multiply the fractions in, probably. 1/2 plus 1/4 x plus 1/8 x squared plus 1/16 x cubed. This one up here is 1/2 minus 3/4 plus 9/8 minus 27 over 16 x to the 6. Okay. Now back to the original thing up here. We can say that it's approximately -2x plus 3. Now the approximation that we made in green. 1/2 minus 3/4 x squared plus... Someone dropped the x to the 4th there. It definitely wasn't me. 9 over 8 x to the 4 minus 27 over 16 x to the 6 plus 5 times, now the approximation made for 2 minus x to the -1, 1/2 plus 1/4 plus 1/8 plus 1/16. Okay. Now if you enjoy feeling pain, you can multiply all of this out. I'd rather not do that unless you really want to see it hourly dose of internet, but I think we've just done the main task here, which is getting these approximations and plugging them in. Any way you want to shuffle it around here, it's kind of a matter of preference, to be honest. Or if you want to see what the end result is, I could plug this into Wolfram Alpha. But this is going to be a lot of algebra to simplify that. Uh, maybe it does, maybe it doesn't call it, I don't know. It's actually quite easy to do. Don't be lazy. I mean, it's not the worst thing, but like, it's just, it's just algebra, man. Uh, so I guess according to Paul, you do have to have the absolute value of x be less than 1. Actually, in the formula, the absolute value of x less than 1, but our x, we would actually need to require 3x, 3 over 2x squared to be less than 1. Like the thing we actually use as x in the approximation. We don't even need the absolute value, but I'm going to put it there anyway. I'll put it into Wolfram Alpha. If doing 2 binomial approximations by hand, it isn't enough to prove that I'm not lazy, then I can't help you. I mean, that's where I'm not clear on the phrasing, Colded. I don't know if they want us to go up to the cubed in the in the formula, or keep expanding until we get a cubed term, which means I should have stopped one earlier for that one involving x squared. Just I'm just not quite sure what that means. Oh, this is a great form. We should get into this form by hand. That'd be great. That's one that we would actually want. The math you're scared of? Just dirty algebra. Not even like abstract algebra, just regular algebra. Hey, look, I did it by hand. All right, I'm not seeing anything else from you, so let me hear the question about that. Uh, Jadzulane, I'm probably saying it wrong. Can you explain diagonal, triangular, and symmetric matrices? Not offhand, no. I mean, we can look it up and talk about it. My linear algebra is not the strongest, though. A diagonal matrix is just... Okay, yeah, that is what I thought it is. A diagonal matrix is any matrix where you only have numbers on the main diagonal, or like non-zero numbers. Yeah, so Jad over in the YouTube chat asked that. And so I think these are just kind of formats of matrices. So a diagonal matrix just, it has any entries along the main diagonal, which is upper left to bottom right, and zeros everywhere else. So on top and below. I think a triangular matrix is nearly the same, but like only like only a half of that is zeros. Like the upper triangle or the lower triangle can be non-zero, or maybe only one of them. Okay, yeah. So a triangular matrix is very similar, except you instead of having zeros both above and below, you're allowed to have non-zeros on just above or just below. This isn't the best. I feel like they could have filled in some of this white space here, but the point of this format is like in the lower left, you can have any entries you want, but then in the upper right, you have all zeros. And that's apparently called a lower triangular matrix or left triangular matrix. And you also have the opposite case where you have zeros in the lower left and anything else you want in the upper right. Finally, a symmetric matrix, I'm not sure. The first way I could kind of recall a symmetric matrix. Oh, is the transposition equal? Oh, okay. I've seen these before, sure. I just haven't done it in a while. So a symmetric matrix means that this one is I want to draw for this one. A symmetric matrix means that A equals A transpose. And so I'll talk about what the transpose is in a second. But the thing to notice with this symmetric matrix is that these 7s match, these 3s match, and these 5s match. That's what it means to be symmetric. And the main diagonal, this one, does not matter. We just care about the green slashes that I wrote there. And what this bit means, A equals A transpose, is let's take a non-symmetric matrix because that'll be a bit more clear what's happening. I'm just gonna do the good old-fashioned 1, 2, 3, 4, 5, 6, 7. This is my matrix B. If you do the transpose of a matrix, you swap the rows and the columns. So this first column is going to become the first row. And there's a neater visual way of explaining that, which is the 1 stays put because it's on the main diagonal. The 2 and the 4 swap, and the 3 and the 7 swap. So it's going to look like 1, 4, 7 across the top now. And now the second column is going to become the second row. So 2, 5, 8. And then the last column will become the last row. 3, 6, 9. And so you've noticed, all we've really done is just swapped kind of those elements there. And that's really happened with the transpose. And the main diagonals of each is still the same. So a symmetric matrix is where a matrix equals its own transpose. Because if you do the same thing, if you do the same thing to A here, like you just get the same matrix back. It's not really a different thing. So that's what it means to be symmetric. I hope that helps. Let me know if you have any questions about it, though. No worries. All right, we might go back to doing physics studying because I think we got a little break from viewer questions. How does this tool work with page breaks? Not very well. Okay, now I know. It does not work well at all, is the answer. I want to take this crazy question. I'll keep the work up for the rest of the stream in case it becomes relevant again, but I want to transfer this thing onto its own page so I can. Let's get it out of the way. Band diagonal matrices can be inverted in big O of n squared? Band diagonal? Let's see what that means. Non-zero integers are combined to a single band. Okay, so it's a diagonal matrix, but the adjacent diagonals may also have non-zero entries, I guess. And you're wondering if they can be inverted in quadratic time. Uh, I don't know the algorithms for getting the inverse of the matrix in the first place, I guess. Because I think the methods we usually do by hand work for humans, but I feel like I've heard that computers can do it way faster using really weird algorithms to do by hand. Yeah, sorry, I feel like I don't really know where to start with this. I feel like you need to name an algorithm, or you would need to name an algorithm to actually accomplish this with. And I mean, also, I never actually analyzed an algorithm for myself for how it increases the time. I know generally how to interpret it, but I don't know. I don't really know how you analyze them to figure it out, to be honest. Well, that's the what the question was. It's like computation time coded. It's called Big O notation. Um, it's basically saying that oh my gosh, the time to execute the algorithm increases with the square of the size of the matrix. You could have like exponential time, that's a really bad algorithm, or cubic time, or something like that too. Maybe bad is the wrong word, but really slow for a big enough thing. So yeah, I think I just gotta say that I don't know the Silverbird's question, but if anyone else has an idea, please do speak up. Yeah, so Silverbird is talking about a band matrix, which is like a diagonal matrix, but you might have a couple more diagonals that are filled in. Hey, underscore. So like apparently a band diagonal matrix could be like 1, 2, 3, 4, 5, dot dot dot. But you could also have like the adjacent diagonals filled in too. But then the rest are all zeros at some point. And so having that assurance of zeros probably saves you computation time somewhere, but hell if I know where. No, no, no. I thought the same thing at first, that it was like a typo, but um no. The inverse of just a diagonal matrix, is that easy to get? I don't know. Yes, okay. I feel like it should be, but I couldn't think of the actual technique. Oh yeah, yeah, duh. Oh, sorry. Colton, you were maybe asking a different thing when you said what's in the queue. Um, oh gosh, what is this question? Oh, yeah, and just like that, Fembox, I took it away again because we have to integrate the step function again. The answer is apparently 3/2. This looks like eek. Spoiler alert. Oh, I mean, if well, this one already seems like something that's gonna be really difficult to figure out. Threek. True, yeah, threek. Dang it. That well now the letters won't line up right unless I wait. So the value of 3ek/2. Wait, local extrema at x equals k. So we want to take the derivative? So for the sake, f is a function of x. Hmm. Oh, RG, it's been a minute. Hope you've been well. Will I be half of a 3? Yeah, I would. Spinning y equals xt. T being a variable, it gets converted into a single integral, but I'm stuck there. Are you taking y as a function of x? Maybe, I don't know. Super Threek? Because of the cape? Oh my god, Jed. Try to remove the greatest integer function. Yeah, I think a normal way of doing that is with summation. With greatest integer is floor. The x can come outside the other integral. Wait, is that 0? Oh, in terms of the bounds? Oh. But isn't this 0 though? The second one? Isn't this good? No, never mind. It's not. It's not. It's not. It's not. It's not. Oh my god. It's the opposite. Um. Yeah, yeah. Tyler, hey. You're saying to try x equals a half. Greatest integer, I think, is normally floor. It's the greatest integer less than or equal to a given real number. I mean, it already... So, Coldy, you're saying to take y equals to x of t, and it gets converted into a single integral? I don't quite... Or x times t? Either way, I don't quite understand why that would be allowed. Um... Oh, you're saying x times t. Yeah, I don't get why that would be allowed. You can't split the integral into two because it's not y integrable close to 0. You're saying it's better to have it as 1. It does get unbounded around there. So you can't split out the minus sign. Right, yeah. The way that I tried to do initially. What we can do is... I mean, I just don't know why it would be allowed. Like, I feel... I don't know. It just feels very random to say y equals xt. Do I have these flipped? That still doesn't make sense. This is going... It's going to go from 1. No, this isn't right. Yeah, this is what I want to do with this, but I'm not getting the bounds of the integral right. X over n plus 1? Mm. It's pretty like I don't know why they do it either, but I've seen it a lot. I don't like it either, but Um, this doesn't work the way that I have this written though. Why? And I don't know why. How do I make it work? Y equals 1 over k? So we change variables, maybe. Separate 1 to x first. Oh. Hmm. That seems sensible. Yeah, Cytos, I've done one that's like this with a lot of help. Uh, wait, is it? Oh, all right. See ya, RG. Thanks for sharing your thoughts. If we do get stuck, I'll try the x equals 1/2 thing, but I feel like we should be able to split this up into summation and go from there. Yeah, cool. The x less than 1 piece does let us make this statement here, at least, that I have in the first line. What's up, Lucas? Uh, the fractional part of x times floor 1 minus y? Oh, God. Um, the negative of that? Yeah, Lucas. Those are the foundation of calculus. Um, they're gonna keep coming up. For certain like sections of the class, you'll be able to avoid them, but you won't be able to avoid them entirely. So we're just running about that equality. That's not correct? Okay. I'm just gonna believe you because I don't even know how to begin with that. Try turning it off and on again. You know, Tyler, that's a great idea. Um, there's definitely some ways that they can trick you, but if you ever want to like, I mean, I know you're about to go to bed, but learning intuitively what limits are is not so bad. If they're making you do epsilon delta stuff, it does get kind of bad, but yeah, usually you do limits and then derivatives. So inderivatives are f prime x. Um, shouldn't this bound actually be... I don't know, but like it needs to be like I don't know what that bound needs to be, man. X over n plus 1 to x over n. Well, then if I make this statement, I don't want to chop off the first line. This would start... But no, this doesn't really make sense to me. It doesn't make sense to me. Oh, wait. Would this... x over 2 to x... Oh, maybe this and that are the same thing. Because x over 2 to x plus x over 3 to x over 2 plus x over 4 to x over 3. And I think eventually it's going to be 0 to something up there. Seeing x to be in the denominator? I don't know, man. Kind of cooked for tomorrow, though, because you needed to learn biology, but I kind of suck at learning stuff for the sake of it, because it just happens. Yeah, that's rough, Lucas. I wasn't a fan of biology or chemistry or stuff like that requires you to just, like, memorize stuff. Uh... Hold it as saying... If this is true, n less than n plus 1. So y is on x over n. But y also goes from 0 to 1. Like, that's what I'm trying to capture the original, like, 0 to 1 bounds. And I'm not sure if this first statement is, like, this n might be different from my n, and that's okay. I'm just trying to figure out how we would use that other n. Kowalski, analysis. Hey, demons. Oh, Tyler, I need to call you out. I was watching a VOD of a streamer I like, and I saw you type in there. I was like, oh, hey. But, Sark? I thought it was, like, super funny to, like, see a name that I recognize. I never typed there, because it was, like, a pretty big, like, channel, but I watch his VODs pretty religiously. I'm in vaudeville. Um, oh yeah, I guess maybe that would be that part isn't super important because we're doing with the integrals anyway. When your childhood pastimes, same inbox or just like the mission to respawn in general. So good. So we're trying to integrate this thing, but we're like, why are we trying to take the derivative? We're trying to find extrema. I guess because we can't get rid of y, can we? Be a function of x, and maybe that's why you were saying the y equals xt thing. Yeah, it means that's what we've been trying to do, but I can't quite make it work. And I need to look at a similar problem that I've done with this. Because no matter what I do, I just can't quite figure out what bounds to make for the integral. Um, okay, but we'd be taking the derivative with respect to x, but the integrals with respect to y. Oh, and that's why you were saying to do that. X should be a constant. With respect to y. So we should be able to substitute it like a scalar, so use y equals xt. You can directly calculate the integral from x to 1? I don't see how. This might be okay for the 0 to x portion. It feels kind of okay. Um, Coda is saying that if we can validly say that y equals xt, then the function becomes t is a constant, I guess. T is a variable. Okay. Well, then I don't know what we're integrating in terms of. You have x less than y. Oh, okay. I see. Yeah. Um, Colton, what underscore is saying is that in this piece of the integral, x is less than y because y is going from x up to 1. So just by how this thing is constructed, x is less than y. And so this piece is 0. That piece is 0. So it's just going to be 0 minus 0 is 0. That's helpful. I mean, so if this summation works, then uh 1 over y is 0. Oh wait, how do I know that? Do I know that? 1 over y is 0. Why would 1 over y be 0? I don't know why. What? No, it wouldn't be 0, would it? I wasn't questioning. Hmm. Uh, this piece maybe isn't 0 then. I don't know what it is, but I don't know, like, how do we directly calculate that? Yeah, Cytos, I guess. Like, are we left then with this? That we still need to deal with in some way? Y to the 14 minus 3 gajillion is equals 69,420. I think you're exactly right, Tyler. Thank you. It was a bunch of work. You need from n 1 over n plus 1 to 1 over n. Okay, that feels like a good sign. I had to count my dogs here to solve that. Hmm. Derivative of pi squared? 0, I hope? Unless using pi as a variable, which shame on you if you are. Okay, well, the first piece I don't quite know what to do with. The second piece, theoretically, we should be able to get rid of the floors. Underscore, I think in the cursed land of economics they do. Hey, 750. You ate water. Nice, nice. I think, but disrespectful towards pi. Solution on stack exchange, I recommend understanding it. Yeah, I'm good with looking at a solution pulled. If you integrate 1 over n plus 1 to 1 over n, the floor 1 over I becomes n factorial. Okay. Interesting. Oh, you're just excited. It's just n. Okay. If you want, you can put the link to the stack exchange, I guess, in the Discord. YouTube doesn't allow links. Or I'll just find it myself, I guess. Here we go. Is this the same thread? Okay, yeah. This isn't allowed. Huh. Or you get a divergent series? Oh, no. Okay, the thing that I tried splitting up into two integrals. Okay. Oh, it's the thing that Silverbird said? Or similar idea? Okay, not the exact identity, but thinking of the fractional parts function. This is crazy. I don't know what's happening here either. Please tell me someone is asking a question. Nope. Very elegant. I I understand how this substitution would work. I don't understand why it's now that makes it the difference of two well-defined integrals. If I accept that as true, uh, then I then we're splitting this up into an integral from 0 to 1 of this thing, and an integral from 0 to 1 of this thing. And it looks like this person does the second part with u of x, which I don't understand how they did any of this. But I also don't see where do they address the first part of the integral. xu1. Oh, the first part is a special case of the second part. Oh my god, bro. And I don't know what k is. Oh wait, k is the index. Yeah, I'm sorry, Colton. I can't explain this to you, and I can't solve this problem. I don't understand anything about this, to be honest. I'll drop the link in chat in case anyone wants to look at it more for themselves, but this wasn't the YouTube chat. Oh my god, yes, Raven, please do. The more dumb the question, the better. I'm just kidding. I wouldn't actually think that it's dumb, but I'd love a question where I actually know like what to do, not a question like this on the screen. In the meantime, I'm gonna clean up my file here. Wait, should I keep this? I'll keep it. Yeah, basically $10. I guess it doesn't rely on super vague trig identities, which was my biggest issue with a lot of ones I was seeing before. I don't know if you're here for. I was able to figure out this one that we had at the very start of the stream. I guess I think I figured it out, but that most recent one, I don't know. The answer is apparently minus infinity, but you get a half. I see you posted it. ChatGPT gets minus a half. We're plugging a very large negative number into this thing. Okay, I have no intuition for what this should do, but JE torture true. Yeah. Holden is agreeing with you, Fembox, about it being JE torture. But whenever I see a radical plus or minus something, I always want to multiply by the binomial conjugate, which I'll explain what that means in a second. I only just recently learned that it's called the binomial conjugate. But I want to multiply it by root x squared plus 1 plus x now instead of minus x. That's the conjugate part. Over itself. And normally you get something that's possible once you do that step. The x stays out front. The root goes away. That's the entire point of doing that. Minus x squared. Root x squared plus 1 plus x. Okay, well, in the numerator, x squareds cancel. We get just x over root x squared plus 1 plus x. So now from here, this should qualify for L'Hopitals, but I think it'll be a lot easier if we factor an x out from the denominator. I'm going to do that. So I'm going to start with the square root. I'm going to factor out an x squared from the square root. So that'll turn into just an x times, 1 plus 1 over x squared plus x. And that's because I kind of skipped over a few steps in there, but it's because root x squared plus 1 is equal to root x squared 1 plus 1 over x squared. Just explain this up a bit more. And then you can split this up into two separate roots. Root x squared times root 1 plus 1 over x squared. And then root of x squared becomes that x right there. So that's all that's happening from this step to this step. And the point of that is that now in the bottom, we can factor out an x. Absolute value of x. True. Side is getting minus a half. Interesting. The absolute value of x. I think it is important. Oh man, you're right. Dang it, Colton. Okay. I should have put absolute value. Because the square root of x squared is the absolute value of x. But that makes this more annoying to evaluate. A negative number seems reasonable because if you plug in a very large negative number, this is a positive number inside the parentheses. Yeah, I got the SI as a saying, because this bit is positive and that bit is minus a negative, so it becomes positive. So you have a positive number times a negative number on the outside. Okay, seeing how there's difficulties now with the absolute value of x, I kind of want to do L'Hopitals. Or could I do the reverse direction? Or maybe what's more clear is I take this and I multiply it by 1 over x divided by 1 over x. If so, x equal to negative. Oh. Dang it. Okay, fine. I think the way that I was about to write would also work and avoid that difficulty. But yeah, no, you just gave me the answer, or like that's the key right there. So I wonder if we made the same mistake, Raven, but or it's a similar mistake. If we're going x to negative infinity, this absolute value of x is going to be negative x. Wait, is that... What do we get when we plug in, though? This is potentially bad, isn't it? I can't do this mentally. If we cancel the x's, aren't we getting infinity? This is infinity. I made a mistake, evidently. I'm gonna graph this thing. Is it supposed to be a constant? What a weird limit. It's supposed to be minus infinity. Okay, that seems reasonable. Yeah, and so I'm getting positive infinity. Okay, maybe let's throw out that approach. I wonder if I implicitly did something wrong there. No, 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 it's negative infinity only. No, no, Raven, I was so much rather work on this question than the last one. It's a negative infinity only. I don't understand that, Colded. How are you getting a positive number from a negative with a square root? Denominator is less than 0. Oh, change it to a plus it converges? That feels weird. I guess because it's negative infinity. I don't. I understand denominator is less. It's a very big negative, but it's squared. That can't be true. What? The negative square root. That is not more than positive 1. No, the answer should be negative infinity. I just don't know how I'm not getting it. So I'm just gonna I'm confused on I think I'm implicitly doing something wrong in this step. I'm gonna go back to the thing I was saying before with the 1 over x thing. And if that doesn't work, then I'm gonna do L'Hopital's. And that should definitely work. I was just trying to avoid having to do annoying derivatives. But If the time, or if duty calls, I will do it. This is just going to be positive infinity also. I'm doing Lopitals. Actually, that, you know, what I wrote was actually fine for the first step of Lopitals, except for that piece. Negative infinity is just sometimes weird with limits, and I think that's where I'm getting tripped up here. Hey, Shane. How's it going? X over root x squared plus 1 plus 1. Does this work? Does this fulfill our dreams? Ah. Should it just be done intuitively? I mean, maybe, yeah. Um, you could figure it out intuitively from like what Cytos was saying, where like positive number minus a negative number, both are unbounded. It's an unbounded positive number times an unbounded negative number is negative infinity, is the intuitive explanation. Last hour has been okay. Previous hours since waking were garbage, but such is life. You left our Super Bowl junk food for comfort. Okay. Well, at least that's, you know, an upswing. It's not just all bad all day. I've been slowly making my way through your adventures in history for Japan. It's been my podcast as I play Baldur's Gate 3. So thank you again for linking that. Um, we should be able to figure out what that is. It should be -1, but that gives me positive infinity. How? Why is this limit so weird? Factor x squared out of the square root. Well, that's what I was doing before, but then it got weird, Cytos. Um, like, are you saying like maybe from this step I should factor out the x squared? So I thought I was doing that right, and then... Oh, I'm sorry, Colden. Less than 0. Okay, fine. We'll go back to this stage. See, the absolute value of x is just -x. Uh, so you're saying, like, even from here, I was making the wrong conclusion of positive infinity. It's like minus 1 plus 0.001. Okay, so this is... You're saying this piece is basically negative root 1.000 whatever 1 plus 1. So it's overall a negative number. Interesting. Okay. I guess that makes sense. I hate that we have to think about it that hard. So Raven, I think the point of this is that like normally for a limit you would just call this 0 and send it home. But I think Colded in the YouTube chat is making the point that it's never actually equal to 0. It's getting very close to 0. I did that too. The function is more like it has x equals 1, and it's like just this square root piece is going down to 1 from above. I guess we're worrying about negative infinity, but it's the same thing over there. And so it's just slightly more than 1. So if you put a negative in front and add 1, you're getting very small negative numbers. And that's why it's negative infinity. Because you're specifically... We should actually just graph this last thing. Plus x. Get rid of the red. Okay. And so, wait. Oh, that's supposed to be a 1. It's supposed to be 1. It's supposed to be 1. It's supposed to be 1. God, I was really worried there. Okay, and so graphically, we are getting the same negative infinity answer here as x goes to negative infinity. So that's a good sign. And the explanation for that is that this piece, the entire square root piece, is just slightly more than 1. So if you take a negative number that's just slightly more than 1 and add 1 to it, you're getting very tiny negative numbers that are getting smaller and smaller, but still always negative. So 1 divided by a very small negative number is negative infinity, annoyingly. Limits are way cleaner when they go to positive infinity. Ugh. Thank you for the help there, Colden. Yeah, and honestly, Raven, I think what's easier, like, like that's a really difficult thing to just spot. I think trying to get the intuition for how the limit should be, it was important for this one. Because otherwise I would not have realized that I did something wrong if I was doing this blind. So, yeah, I guess it I should have spent more time trying to figure out the intuition for this, because that would have been the best indicator that um, something messed up was happening. We did get it in the end. Thankfully. Thank you for the question. Um, all right, unless someone else has another question, I might wrap things up with looking at this physics problem, but please do speak up if someone wants to ask something. So the start, we have all potential energy. At the end, when the spring is all the way up, we have two kinds of potential energy. Potential energy from the spring that's being stretched some distance we want to solve for that I'll call H for maximum height, plus gravitational potential energy. How to diagonalize a matrix? Like with eigenvalues? I think so. Like eigenvalues and eigenvectors? And so I think we said these two things equal to each other and solve it for x or h, same thing. Definitely not the same thing, but I don't care about the difference. A equals PDP inverse type things. I mean, I haven't done it in a while, but I think I could remember it. Since we're solving for h, I guess we're gonna need some quadratic formula in our lives. M squared g squared plus 4, but there's two halves, so that cancels. K squared L squared. Sure. Over K. There's this video on TikTok. Escape the matrix. You can't even diagonalize one. Oh my god. The Matrix would have been a way more boring movie. Oh, hey. Academy of Useless Ideas. Thank you so much for the raid. Well, welcome in, everyone. I've looked at your stream a bit. I haven't watched as much as I want to, though. Hey, Syntax. So yeah, welcome in, everyone. I'm Don. I do math help. At least I attempt to do math help. I can't always help. Stuki, thank you if it was you who suggested me. Welcome in too. Yeah, for anyone who's here on my end, do check out Academy of Useless Ideas. Fellow math streamer, all that cool stuff. I appreciate it. Um, don't tell me this is just the answer. I assume the positive one. And there's sometime more in Problem Streamer. Oh, really? I really got to watch more then. I know that Matt Spellbook has been doing some physics. This is a J Advanced previous year problem? Really? This is just from a textbook that I've been using. You don't understand raids, but maybe one day I will. You did it right, as far as I can tell. It's just a nice thing that you can do at the end of the stream to send people whatever way you want. Their mathematical theory of raids. You know what? There actually is. I remember Zach, or Eats the Two-Eyed Pie, kind of like made one using Markov chains. If people were to like keep on raiding each other. What I'm doing now. Oh, that's funny, Colton. Weird question. What exactly are contour integrals? I'm looking into integrals over the reals of the form sin x over p of x, where p of x is a polynomial function. This is how I turn into a contour integral. What do I need to study before I get to contour integrals? Are those a complex variable thing, or is contour integral another word for line integral? I don't remember. Let's find out. It is the complex variables thing. You would need a good bit of complex. I mean, you might not. You probably would need to know the theory to do one. But like, you need to look into like complex variables, I guess. Um, I feel like Zach or Penn Center could give you better direction than I could. It's possible I've done these before, but I don't remember them at all if I have. Actually, no, I don't think I have. I think I've read about them a tiny bit. Should you know multivariable calc stuff? I think it helps to know some. I don't think it's the end of the world to learn as you go, though. I think my complex variables or complex analysis knowledge is pretty weak. But I think you can kind of pick up the multivariable calc you need as you go, I want to say. Yeah, if you want, I know people have talked about a book called Visual. Oh my gosh, let me find it. Visual complex analysis. I've heard people like this book, and I assume they go over contour integrals. Let's find out. Dude, bring me to the table of contents, please. There. um, differentiation, non-Euclidean geometry, winding numbers into okay, complex integration. They do go over that. So if you want this book, let me know, or send me a message on Discord. Um, but yeah, that's kind of like the direction you'd have to go in. Yeah, Finlux, we have such a cool little like community of people here. Come for the pleasant conversation, stay for the humbling experience. True, Shane. Oh my gosh. I've been getting humbled a lot today. There's been some difficult questions. This one was a doozy, but I could at least solve it. This one, it could have been worse, but I did it wrong the first time. This one, I should have done right the first time, and I didn't. Oh, I deleted. There's one that I just could barely even start on. That was definitely the hardest one of the day. Last one, just time I actually live that while the stream exists. Yeah, I don't know. Like that's always kind of our thing is people like to ask like tough questions, but that like it kind of makes the conversation go in a direction that's like less accessible to like people who don't like specifically study math for years. It's kind of a hard balance to strike there. Is this basically our answer right here? Like, I don't really see a simplification. We know if we take the positive root, we know it's a positive power. But I think that's kind of the answer. The units check out. Actually, watching the craft happen if I couldn't replicate the process. That's fair. Um, what's happening here? We have kg squared, m squared, seconds to the fourth. We have Newton squared, meter squared. Why did I say that's kg? M is oh my God, m is meters, not mass. Or m is what is no m is kg. M is kg. Oh my God, bro. My brain is slowly cooking. Okay, these units do work out. To be length. All right, let's see if this matches the answer. Problem 10. Sounds like to do math while listening to the stream, even though I sometimes don't keep up. That sounds thank you, but that sounds like it sounds like it'd be difficult to try to do math in your head while hearing someone say numbers out loud. It's like doing math on hard mode. Oh, they're doing it with respect to distance beyond relaxed length. You don't think in words. How do you think then? That's pretty much how I always think, unless I specifically try to picture something. You don't even know. Fair enough. You don't have to know, I guess. Did they ask me to get distance beyond? They said maximum height above the ground. I feel like I got that directly, and they're doing a weird thing. Mostly GIF or GIF. Okay. Or I guess you just mean like in animations in general. That really helps a lot with some things and probably hurts with others, but well, that's not good. Uh, am I missing a simplification? I don't think I am. Hmm. Oh, I know what I did wrong. I get why they're measuring things with respect to distance above relaxed length. Okay. We're going back to the drawing board on this one. Well, not back to the drawing board, but uh it's this piece that is wrong. If I'm doing it with the construction that I made and not their slick way. They do things the bad way. This should be h minus l squared. Right? I think so. Does this give the right answer now? We're going to find out the hard way if it does. H squared minus a quarter KHL. No, not a quarter. Just one. Plus a half KL squared plus MGH. Ugh, it's a much more annoying quadratic now. We only have one h squared term. That's nice. We have two h terms. You like this, Fembox? Okay. It's a good sign. Oh, the KLs go away. Or KL squareds go away. Interesting. Okay, so that gets us... Okay, cool. So we didn't have to use a quadratic form in the first place then. So either h equals 0, which we already knew, or 1/2 k squared h minus m, or plus mg minus kl. Solve this for h. still feels like too many letters for my liking. I should have been suspicious with my last method as soon as I didn't get h equals 0. What was the answer supposed to be? 2L minus 2mg over k. Wait. It's supposed to be 2L minus 2mg over k. Why am I getting too many k's? Why is this k squared? That should be just a k, not k squared. Oh, I just randomly added in a squared for fun. Okay, now this is the right answer. It's never just a k. Hey, Phobos. Ugh, okay. I did, man, that trick with the springs always gets me. Um, I've got a decision to make because I desperately have to use the bathroom. But I also think I want to call the stream soon. Which maybe that's two factors pointing me towards just calling the stream right now. Why is my sign opposite to the answers? Oh, hell if I know. I wasn't paying attention. Was there supposed to be a minus? I might have just flipped a sign for fun too. Oh, it's supposed to be minus, you're right. Oh, I just flipped a sign for fun. I just like changing it. Or like, you know, it's like, add a squared here, make that positive for fun. Perspective, that's why. There we go. Okay. I think I'm gonna call a stream here for the day. I will be going to class tonight. So in an hour and 15 minutes, go check out Eats the 2i Pie. Oh, Papadoria. Do you have something to say about your problem? I can hang on for a minute as I look for someone. Yeah, I'm sorry, Papadoria. If you have something quick you want to say, please do. But who am I rating? I'm not sure, Raven. I haven't looked yet. If you have something you want to see, let me know. What, am I allowed to call the stream drum cat? No. Oh my gosh. I hope I'm allowed to at least like use the bathroom here. Before you got that big nasty function way simpler. Oh, okay, nice. Sorry, I want to go and like make some food and stuff before class. Otherwise, I would like look at it. I see Kim the Tutor is streaming right now. Oh wait, also Gold. I rated Kim the Tutor last week, didn't I? Yeah, I'll see you around, Papadoria. I'm putting the YouTube stream off here. So, Papadoria, anyone who's here on YouTube, thanks for hanging out.